Hi, my name is Melody. Today I want to talk about solubility of a gas in water. Let's see a case first. Some substances found in aqueous environment are considered toxic at certain concentrations, especially when these substances are not very soluble in water. An example of such a substance is oil. Oil pollution from land and water accumulate in bodies of water and change the properties of aquatic ecosystems. This is one of the leading causes of rising global water temperatures. As a result of these rising water temperatures, aquatic species that were once able to thrive in these regions can no longer continue to survive. To look at this example further, the fish that live in these habitats ingest the product of pollution and this oil. The oil damage their organ can prevent fish from performing oxygen exchange. From this picture is here. Thus, these fish fail to survive and species can become extinct. In turn, animals that depend on this fish for food, including humans, are not able to consume this fish. For example, Arctic seals who are depend on fish as a main source of food could become endangered due to not being able to assist a complete diet. This is an ongoing cycle where the entire food chain that stems from fish as a source of food is affected. From the case, we know oil are not very soluble in water. So, what is solubility? Solubility is the ability of a solid, liquid, or gaseous chemical substance to dissolve in solvent. And from a solution, the solubility of a substance fundamentally depends on solvent use, as well as temperature and pressure. The degree of solubility depends on substance from infinitely soluble to poorly soluble. The term insoluble is often used to poorly soluble compounds. Let's see some real-life example of soluble. Adding sugar to hot coffee, take medications that absorb into the bloodstream, dissolve of toxic metals and chemicals into water supplies. Definitely, this example are solubility of a solid in water. So, what is the example for solubility of a gas in water? Here is two examples. One, the first one is oxygen dissolved in water to help fish to breathe. The second is Cl2 dissolved in water become HOCl, and this is used in the treatment of skin problems. So, let's talk about what will impact the solubility. The first factor will impact the solubility is pressure. Pressure has a negligible effect on the solubility of a solid and liquid solid, but it has a stronger effect on solution with gaseous solid. For example, when open the soda can, the high pressure may lead to a hissing sound. This pressure ensures the soda stay carbonated. The second factor will impact the solubility is temperature. Solubility will increase with temperature for most substance. Show as this figure. For example, more sugar will dissolve in hot water than in cold water. On the contrast, the solubility of gas displays the opposite relationship with temperature, which means while the temperature increases, gas solubility will decrease. So for the next part, let's talk about how to calculate the solubility. Solubility is measured either in gram per 100 gram of solvent or number of mole per 1 liter of the solution. Before we do the calculation problem, let's talk about what is Harry's law. Harry's law is a gas law that states the mass of a gas which will dissolve into a solution is directly proportional to the partial pressure of that gas above the solution. And here is the formula of Harry's law. C equals K times P. C is the solubility of a gas at a fixed temperature in a particular solvent. K is Harry's law constant, and P is the partial pressure of the gas. So, let's do the calculation. The question 1. At 25 degrees, the Harry's law constant for pH-free gas in water is 8.1 times 10 to the negative 3 molar per atmosphere. Calculate the mass in gram of pH-free gas can be dissolved in 1,200 ml of water at 25 degrees and a pH-free partial pressure of 1.9 atmosphere. So, let's write down the Harry's law first. C equal K times P. From here, we know K, the constant is 8.1 times 10 to the negative 3 molar per atmosphere, and the pressure is 1.9 atmosphere. We can calculate the C first. C equal 8.1 times 10 to the negative 3 molar per atmosphere times 1.9 atmosphere. We get C is 0.01539 molar. So because we have 1,200 ml of water, which is mean we have 1,200 ml solution. We want to know mass in gram in 1,200 ml of solution. So we use molarity to find mole. We need to have volume or liter. So for the next step, the liter of pH-free solution, we convert it to the mole of pH-free, and then we get the molar mass. So how to calculate this? First, let's use 1.2 liter of solution times. Well, here the 0.01539 mole is mean 0.01539 mole pH-free in 1 liter. So here we have 1.2 liter, which is 0.01539 mole pH-free divided to 1 liter, and then we times the molar mass for the pH-free according to the periodic table, which is 34 gram. Finally, we get the answer as 0.63 gram. So for the next question, if the solubility product constant of barium fluoride is 2.4 times 10 to the negative 5 molar, what is the solubility of barium fluoride? So we know barium is 2 plus, which is mean lose 2 electron, and F fluoride is 1 minus, which is mean gain 1 more electron. So according to the KSP definition, we can write KSP equals Ba2 plus times F1 negative square equals 2.4 times 10 to the negative 5 mole. We set Ba is x and F is 2x. So we get 2.4 times 10 to the negative 5 equals x times 2x squared. We simplify the equation. For the next step, we get x is equal 1.8 times 10 to the negative 2 mole. So it means the solubility of barium fluoride is 1.8 times 10 to the negative 2 molar. And here is the reference. Thanks for watching and listening.